Alright, so in this video we're going to be talking about the inverse and the determinant of a matrix. It's going to help us solve a matrix equation. So let's go ahead and start by thinking about this problem. Can you solve this matrix equation? We have this matrix here that we're going to be multiplying by another matrix to get the matrix here that is 3223. And right now my guess is that the answer would be no. But this is where we're going. It's going to take us a while to get here, so I want you to stay with me here and make sure you're focused as you watch this video. Let's start with a similar problem, one that looks like this, and hopefully you can solve this equation. What we'd want to do is make this so that it's not 2/3 x, but we want it to just be x by itself. And so you know that to get rid of 2/3, you multiply by the reciprocal, which is 3/2. And you'd multiply both sides by 3/2. And the reason we multiply by both sides or by 3/2 is because when I take 3/2 times 2/3, the 3's cancel and the 2's cancel, and we simply just get 1x. And so these are called inverses of each other because the multiplicative inverses of each other, because when you multiply them, they undo each other. And you get 1x equals, and then I could take 12 times 3 divided by 2, which is going to be 18. And we know that 1 times x is just x, because 1 times anything is itself. That's the multiplicative identity. And it's called the identity because whenever we multiply by 1, whatever we multiply 1 by keeps its identity, and we just have that x is equal to 18. The reason I wanted to show you this is because there's two things here: the multiplicative inverse and the multiplicative identity that are key to solving an equation like this. They don't even think about when you're solving it, but we're going to need to think about it when we start solving these matrix equations. And so let's start by thinking about a 2x2 matrix, and you can put anything you want in this 2x2 matrix. What I want you to see here is, regardless of what you put here, let's say I put a 3, I'm making these numbers up, a 1, a 5, and a -2. And if I were to multiply these two matrices together, remember I'm doing the rows in the first matrix by the columns in the second matrix. And so I'm going to start with the first row and the first column. And because this is a 2x2 matrix, and this here is a 2x2 matrix, I can multiply them together because these numbers match. And my resulting matrix is going to be a 2x2 matrix. So to get the first element, I'm going to take 3 times 1, which is 3, plus 1 times 0, which is 0. So my first element here is a 3. Staying in the first row, second column, I'm going to take 3 times 0, and then 1 times 1, and that's 1. If I move to my second row, it's 5 times 1, plus -2 times 0, which is 5. Second row, second column, 5 times 0 is 0, -2 times 1 is -2. And what I want you to see here is this. These matrices, it kept its identity. What that means is that this matrix here, 1, 0, 0, 1, is the multiplicative identity. Very similar to what we had back in our last slide, where if I take 1 times anything, it keeps its identity. 1 times x stays in x. Well, now we know that 1, 0, 0, 1 times anything keeps its identity. Keep that in mind. We're going to come back to that here in a little bit. So let's say that we want to show that these are inverses of each other. Remember, we just showed that 2/3 times 3/2 are inverses of each other, because when we multiply them together, we get the identity. And so that's what we're going to do here. We're going to multiply these two things together, and it will give us the multiplicative identity. But now with matrices, the multiplicative identity isn't 1. It's what we just talked about, which is 1, 0, 0, 1. So if these really are inverses of each other, that means when I multiply them together, this is the matrix that I should get. And again, here we have a 2x2 matrix multiplied by another 2x2 matrix. I can multiply them together because those numbers match. My resulting matrix is going to be a 2x2 matrix. So I'm going to start with the first row, the first column. -2 times -3 is 6. -5 times 1 is -5. and so that gives me a 1. If I multiply the first row by the second column, negative 2 times negative 5 is 10, and then negative 5 times positive 2 is negative 10, and that gives me 0. Now I move on to the second row. 1 times negative 3 is negative 3. 3 times 1 is 3, and then when I add them together, I get 0. And if I move on to the second row, second column, 1 times negative 5 is negative 5. 3 times 2 is 6, and negative 5 plus 6 is 1. And so that does give me the multiplicative identity, which is 1, 0, 0, 1, which means these two are inverses of each other. They undo each other, just like 3 halves undoes multiplying by 2/3. Okay, so how do we find the inverse of a matrix? I know when I have 2/3, I can find the inverse of that fraction just by flipping it over and multiplying by the reciprocal, because reciprocals are inverses of each other. Well, how do I do that same kind of a thing when I'm talking about matrices of each other, a matrix? And so there's 2 steps. Step 1, let's say we have a general matrix that's A, B, C, D. We have those specific elements. We simply find what is the determinant. And the determinant we find by taking the A times the D, A times D, and then subtracting B times C. What does that look like in a more specific example? Well, that means if I have a matrix that looks like this here, I'm going to take 5 times 4, which is 20, minus 9 times 2, which is 18. And 20 minus 18 gives me my determinant, which is 2. That's the first step, finding the determinant. This is something that you're going to want to put in your notes on how to find this. This is going to be important for several days, actually. Then we want to find the inverse. And so the second step, the first step is to find the determinant. The second step is to use the determinant to find the inverse. And in a general sense, this is what it looks like. We're going to take 1 over whatever the determinant was, and we're going to multiply it by a brand new matrix. The matrix was A, B, C, D, which is what we have here. Well, the A and the D switch places so that the A is here and the D is here. Those two switch places, and the B and the C become negative. So if I move over to my specific example, I had 5 and 4. Those two switch places and become 4 and 5. And here I had the 9 and the 2. Well, now it's negative 9 and negative 2. And I'm going to take 1 over my determinant. Remember, my determinant was 2. So I'm going to take 1 over 2 and multiply it times that new matrix. So when I do that, I'm going to take 1/2 times 4, which gives me 2. 1/2 times negative 2 is negative 1. 1/2 times negative 9 is negative 4.5. And 1/2 times 5 is 2.5. Here's what this means then. This matrix here and my original matrix are inverses of each other, which means if I multiplied them together, I would get the identity matrix, which is 1, 0, 0, 1. How are we going to use all this? Well, this is how we're going to use all this. Let's go back to the original equation that we had at the beginning of this PowerPoint. This is a matrix equation, and I'm multiplying x. This is a matrix, that x. I'm multiplying that times this matrix 3, 4, 2, 3, and I get this result here. Well, I don't want that. I don't want this matrix there. I want it to be just x equals something. In order for that to happen, though, I have to change this matrix to 1, 0, 0, 1 times x. Because 1, 0, 0, 1 times whatever x is, that's the identity matrix. It's going to stay an x. And so what I need to do is find the inverse of this matrix. And so I'm going to do that by first finding step 1, first finding the determinant. So I'm going to take A times D, that's 3 times 3, which is 9, minus 2 times 4, which is 8. That gives me 1. Then I'm going to take 1 over the determinant, which is 1 over 1, and multiply it times the new matrix, where the 3 and the 3 switch places, so they stay the same. But then the 4 and the 2 become negative, so it's negative 4 and negative 2. And so when I multiply 1 times all of that, I get 3, negative 4, negative 2, 3. And this is my inverse matrix, which means that if I took that matrix and I multiplied it times my original matrix, if I had the 3 here, negative 4, negative 2, and 3, the product would be this matrix. But that also means if I multiply this side by that matrix, I'm also going to multiply this side by the same matrix. And so when I do that, here's what I will have. 3 times 32 is 96. Negative 4 times 23 is negative 92. And so that is positive 4. And then when I multiply the second row times this column, negative 2 times 32 is negative 64. And 3 times 23 is positive 69, and that gives me 5. And so now I have this equation, but 1001 times x is just x. That means that x is equal to the matrix for 5. So that means that this x right here has to be 4, 5. And if I took 3, 4, 2, 3 times 4, 5, I would get 32, 23. And just to check this out, I know this is getting kind of messy here, but if I check this out, if I take 3 times the 4, that's 12. 4 times the 5 is 20, and 12 plus 20 does give me 32. Then if I multiply the second row times this column, 2 times 4 is 8, 3 times 5 is 15, and 8 plus 15 does give me 23. Now, this is not something we're going to be doing today. We're going to be solving those matrix equations tomorrow. Today, what we're going to be doing, or tomorrow when you get to class, what we're going to be doing is simply finding the determinant of a matrix, finding the inverse of a matrix. And we're going to practice that to make sure we're good at those steps, step 1 and step 2, before we go on and start solving those equations. So what I want you to do is pause the video and see if you can figure out what the determinant of 1 through 3 is, and then start the video and see if you are correct. So here's what you should have had. Here, when we take 4 times 3, we get 12. Minus 6 times 2 is 12. 12 minus 12 is 0. So the determinant here would be 0. Here, when I take 8 times 3, that's 24, minus 2 times 7 is 14, which means the determinant is 10. Here, when I take d times negative 3, it's negative 3d, minus, when I multiply these together, it's going to be minus 3 times 3 is 9, and then 3 times negative d is negative 3d. Well, that's negative 3d minus 9 plus 3d if I distribute this negative sign. Negative 3d plus 3d cancel each other out, and my determinant is simply negative 9. So then the other thing that we're going to be doing on our homework is finding the inverse of these matrices. So you first have to find the determinant and then take 1 over the determinant times the new matrix. So pause the video and see if you can get number 4 and 5 correct. Let's see how you did. First of all, we have to find the determinant. So we're going to take negative 2 times negative 8, or negative 4, which is 8, minus 5 times 2 is 10. That gives us negative 2. And when I multiply this by the new matrix, remember the negative 2 and negative 4 switch places. Negative 2, or the 2 becomes a negative 2 and the 5 becomes a negative 5. So what you should have got for number 4 is half of negative 4 is 2, negative half of negative 2 is 1, negative half of 5 is 2.5, and negative half of negative 2 is 1. For number 5, the determinant is 2, so we're going to take 1 over the determinant, 1 over 2 times the new matrix. So half of 3 is 1.5, half of negative 4 is negative 2, half of negative 1 is negative 0.5, and half of 2 is 1. These are the kind of things we're going to be doing on our homework. We will look forward to doing that tomorrow in class.